Welcome everyone. We're going to begin the webinar on DeVilbiss Episode 1, Compressed Air Systems and Filtration. I'm Melissa Joles with RDA Impact, Kevin Creegan, National Accounts Manager, Automotive Aftermarket, and Jeff Bell, National Accounts Manager, National Accounts for Saint-Gobain, are your presenters today. The webinar will take approximately 35 to 40 minutes. We are recording it and we'll make it available to everyone after the presentation. If you have questions, you can raise your hand in the control bar and I can unmute you, or you can type them in the chat box at the bottom right of your screen and Jeff will answer them during the presentation. Now I'll turn it over to Kevin and Jeff.
All right. Good afternoon, everyone. Thank you, Melissa, for the great introductions. Kevin Creegan here. Great to be speaking with you again, reaching out via web. And I'm looking forward to the next opportunity that we'll have to meet in person, which is slated for October in Nashville at the RDA conference that's going to be held down there. And I couldn't be happier about getting back to the old normal, if you will. This afternoon, we're going to be talking about compressed air systems and filtration. And with me as our presenter is our subject matter expert on all things air compression, filtration, spray, anything that has to do with paint finishing. We can rely on Jeff Bell, formerly of DeVilbiss, but now with the RSG group in Saint-Gobain for the last couple of years. My friend, my colleague, and a real asset to our team. So please do feel free to ask any questions that you might like to throughout the presentation. Raise your hand, whatever. Melissa's going to be standing by to take those questions as they come up, and look forward to a great presentation here today. So without any further ado, I'll turn things over to Jeff, and thank you for joining us.
All right. Well, thank you, Kevin. Thank you, Melissa, and thanks everyone for joining the Impact webinar today. Compressed air systems and filtration is the episode 1 that we're going to start with. Again, any questions, raise your hand, type in your message. You don't have to wait till the end. I'd like to keep this, open forum. So please feel free to type in or raise your hand accordingly, and we'll answer your questions at that time. So we will go ahead and get started. The name of this is called Hidden Thieves, and the reason it was named that is because we're going to bullet point some areas where your compressed air or your air supply can be robbed from you. And as most of you know, or some of you may not know, a spray gun will use more air than any other tool in your shop, and consistently use more air. You can use a DA or a blowgun or something that uses a lot of air for 30 seconds or a minute or two, but a spray gun, when you're painting a car, will consistently use more air than anything. And the other issue with that is the spray gun needs that air to maintain the quality of finish that you're looking for. So this just lists the learning objectives. We're going to talk about different compressor types, size of compressor, how to size a compressor based on your shop, a compressor maintenance plan. From the DeVilbiss side of things, we don't maintain compressors, but we believe we were going to tell you how important it is to make sure that you have some sort of a plan to maintain your compressor. Different types of piping, reasons for whole shop and point of use filtration, procedures for using regulators, minimum filter requirements, when painting cars, and develop and implement point of use filtration maintenance plans as well. Some of this stuff falls on the painter, and as an ex-painter myself, I'll sit here and tell you that it's not my job to maintain filters in a booth, but it's not my job to repaint cars either. So in my mind, it's much easier to maintain a filter system than it is to go back and repaint a car. So this slide here is the typical compressed air system. It's what we call a loop system. So as you see, as the air comes out of the compressor, travels up the wall, it will, go through a dryer. We always want to put some sort of a T or a bypass in front of that dryer system. So if your dryer fails, you have a way to bypass that dryer and your whole shop's not shut down. The loop system itself would be on the right of your screen, the blue, circle or loop of piping. And by having a loop system, you get good, consistent airflow and pressure at every drop. So it doesn't matter if it's the first one where the air comes in or the one farthest away. If it's a loop system, you're going to have even pressure all the way around. Versus what we would call a dead end system, which would be just a straight line pipe running down the middle of the shop. The guy at the end is going to have less air than anybody else. If the first 3 or 4 or 5 guys in front of him are all using air, the air is going to take the path of least resistance. It's going to go to those guys first. The guy at the end has 20 pounds pressure. And anybody that's ever been in a body shop and you look at where an air compressor is set up and how it's piped, you know, it at least goes to the body men first and the painters last. And in some cases, if it's a dealership, it will go to the mechanics first. Then the air will go to the body men. Then the air will go to the painters. And if anybody that was designing these body shops knew anything about this and how it worked, they would do that exactly the opposite way. The compressors should be backed by the spray booths, and the painter should be the first one to get the air, then the body men, then the mechanics. If a mechanic's using a 3/8 or a 1/2 inch air ratchet or impact and he runs a little bit low on air, it's not that big a deal. It's not going to affect anything except, you know, the RPM that his tool's turning. Versus a spray gun, it's going to affect quality of finish. Okay, next. Excuse me. So this slide here, the box on the right, that's 1 cubic foot of air at what is normal PSA, pounds per square inch, at atmospheric pressure. So if I took a cubic foot of air at 68 degrees, which is about what it is here today in Northwest Ohio, that air fits in a 1 foot cubic square box. If I do nothing except raise that air pressure or that air temperature, to 120 degrees, it now takes a 2 cubic foot box. It's expanded that air that much. Okay. The box on the far right is just taking that same air from 14.7, which is, you know, pounds per square inch at atmospheric pressure, to 100 pounds per square inch through a gauge. And now it's a third of the size that it was. So an air compressor does a couple things. It compresses the air. It also heats the air. As the air is compressed and goes into the tank, it is hot. You know, it doesn't create the moisture at that point. The moisture is created as the air travels downstream and cools off. No different. It's just like your rain clouds. Hot air is up above, comes down, comes through the clouds, creates moisture. You get the same thing coming from an air compressor. As the air travels downstream, it cools off. As the air cools off, it creates moisture. And it's our job to give you the best ways to remove that moisture, to give you clean, dry, contaminant-free air for refinishing of vehicles. Okay? So air compressors. The air compressor is the heart of the body shop. I mean, you know, I can't stress it enough. Air compressors get no maintenance, and it's the biggest abused piece of equipment in the shop every day. When that compressor goes down, the whole shop goes down. If it's a big compressor or a couple run in sequence at a dealership, then everybody's down. The mechanics, the body men, the painter, everything. So it's a great, great opportunity. It's a good business plan to have a maintenance process for your air compressor, whatever that might be. Someone comes in and does it, someone internally, you know, and we'll talk about some of those things. So your body shop compressors are going to be either a 2-stage compressor or what we call a rotary screw compressor. You want to make sure you have the correct capacity for your air compressor. We want to make sure we can manage the heat produced as the air is compressed. We want to be able to remove the water and particles in the compressed air and the oil from the compressed air as well. And then ultimately the humidity. Even though we're taking the moisture out, which is the solid content, you still have moisture in the air and we can't see that humidity. Just as a reference for anybody that's, you know, dealing with waterborne shops, and they're becoming more and more prevalent across the country, most paint companies are going to tell you when they put a hygrometer on the end of your air hose, they want you to be below 10% relative humidity in that airline. And if you can be, they'd like you to be below 5. So that gets pretty low, and you can't do that with a whole system, or a whole shop type air dryer system. These have to be done with point of use units, and we'll talk about those as well. Go ahead, Kevin. So this is your typical 2-stage piston type compressor. You have an electric motor on the right. It kicks in, drives the pump that's on the left. the pump spins, takes air in, puts it into the tank. The more it shoves into the tank, the more pressure is in that tank. Most of those run at a kick-on pressure of between 100 to 120 pounds, and a shut-off pressure of 170 to 180 is normal a range. Go ahead. This is typically a rotary screw compressor. You don't see a whole lot of what goes on. Everything is in there. This is a Kaiser. This is a very popular one. You have them by DeVilbiss. You have several companies out there that makes them. The difference in a rotary screw and a two-stage compressor, if I'll just back up a second, two-stage compressors were very popular, 50s, 60s, 70s. Somewhere along the 80s, 90s, or even early 2000s, everybody thought you needed to have a rotary screw because the air was there. The demand was there. Right now, boom. We've kind of taken a step back and looked at that again, because body shops in general don't use a lot of air all the time. They use a lot of air at times. If everybody's running an air tool at the exact same time, if you got, 2 painters and 4 body men, what's the odds of every one of those guys using an air tool exactly the same time? So rotary screw compressors run all the time. They also have vanes, which is basically like a turbocharger on a car, but it's like for air, that is mixed through oil, and you're actually putting oil into your air line. So these have to have coalescer filters built into them to actually remove the oil vapors from the air before it ever goes downstream. So in a lot of cases, we've gone back to recommending your old two-stage compressors over the rotary screws because they're less maintenance as well. Go ahead. This is typically everything you would see inside a rotary screw compressor. You got on your right side is where the air comes in. That would be the box on the right. Just to the left of that green would be those vanes I was talking about. Oil gets injected into those vanes, runs forward. The top left or top right where you see the fan, that would be your intercooler, where that actually starts to drop the temperature of the air right there. Then it goes to an aftercooler. Then it goes through a coalescer filter to remove the oil out before it goes downstream. You still have to run water trap separators, oil coalescers, and desiccant at point of use. Even though all this stuff is inside this box for this compressor, you still have to run point of use units. You're still going to get contamination that comes downstream. It's just going to minimize it through this. So there's a lot of working pieces inside a rotary screw compressor that have to be maintained and taken care of. Go ahead. Okay, sizing a compressor. And guys used to say, rotary screws put out a lot more air. Okay, your standard two-stage compressor will deliver about 3.5 CFM per horsepower, and a rotary screw is about 4 CFM per horsepower. Not a big deal, right? You're talking half a CFM per horsepower. 10 horse compressor, 5 CFM, 20 horse compressor, 10 CFM, on and on and on. Your compressor needs to be sized to meet the maximum amount of air needed by all technicians at the same time. And again, we'll go back and we'll talk about this, but how many shops, everybody's running air at the same time. Another difference between two-stage versus rotary screw, two-stage compressors will run at a higher pressure. They will run it up to 175 pounds. Your typical rotary screws have a max PSI of about 110 pounds. Your two-stage compressors are going to be geared for the environment with a lot of starting and stopping. That's just the way they work, and that's the way they've been set up. And I know guys that have had compressors for 30 years and never had a problem. Rotary screws run all the time. They're not necessarily under a load, but those vanes are always spinning. And when you want your air, it's there right now. It's on demand. You'll have your air. You won't see any peaks and valleys in your air. It won't go down to 110 and up to 170 and all that type of stuff. When you need 100 pounds air, you have 100 pounds air all the time. So, they are more maintenance, and I'm not trying to defer anybody, one way or the other. I'm just, showing you the differences. How do you decide how much air you need for a shot? So we've come together. We put a couple charts. There's one here. There's one on the next slide. This shows average working pressure of these particular tools. The red number in parentheses on the right is the most common CFM that we see based on what's the most used tools and the brand of tools and things like that. So between this slide and the next one, go ahead, Kevin. I would go through my shop and I would say, okay, if my guys are all using 2 fitting blowguns, which we know everybody does, they take 2 fittings and blow them together, screw them together and they keep it in their pocket. That's 50 CFM. But if I'm running compliant spray guns, I'm at 12 CFM. If I'm running HVLP, I'm at 16. So if I take my 16 CFM and I got, 5 guys working in my shop, I need 80 CFM of air. That's how I'm going to size my compressor. If I take my 80 CFM of air and I divide it by 4 CFM per horsepower for a rotary screw, I need a 20 horsepower compressor. If I take my 80 CFM and divide it by 3.5 CFM for a typical 2-stage compressor, I need a 22.8 compressor horsepower, which is not going to be, so you're looking at a 25 horsepower compressor. So you need a little bit bigger compressor to run a 2-stage over a rotary screw. But, Melissa will send this chart out. Feel free to make copies of these pages when you go out. If you're looking to size a shop for a compressor, go around to the body man, find out what tool they have that uses the most CFM, each one of them, give it that total times the number of people working in that shop, and that's the max number of CFM that you could need in that shop. So pretty simple, really. Go ahead, Kevin. Okay, compressor maintenance. This is a big thing, and it's, again, I worked in shops for 18 years. It's one of the most abused things. Compressors don't get maintenance. They get shoved up in the corner. They're on top of the mix room. They get all the dust and oversprayed debris wherever. The only time they get any attention is when they fail. When the guy goes from having 2 compressors running in sequence, that one quit, so we're just running off one instead of getting that second one fixed. Follow the manufacturer's maintenance procedure and schedule. Who's going to be responsible for doing it? My suggestion is you hire the air compressor company. They will have people that do maintenance. They may subcontract it. They know the compressors better than I do or you do. I mean, yes, I can go out and change oil, but I don't know what to look for. How often do I have to change the belt? Do I have to check any torque settings on things? When does the air filter need to be changed? This stuff should all be done on a maintenance schedule. And in most cases, it's probably twice a year. I mean, every 6 months. And if you're doing that as a maintenance schedule and you have a guy coming out every 6 months to do it, I think that's great. You're going to do it more often on a 2-stage compressor because of the starting and stopping. They blow a lot of dust around. So you want to blow off the accumulated dust, change your air filter, lubricate it, all those types of things. And the same with the rotary screw. They tend to stay a little bit cleaner on the inside because they're in this box, which means they can run a little bit warmer, but they run at a lower pressure, so they tend to not have the heat build up for the air that you would see. So just air compressor maintenance is huge, and I just can't stress it enough how it should be done. Go ahead, Kevin. Okay, air filtration. The air quality needed for spray operations is different than you need it for air sanders or any other tool. A mechanic can get by if there's a little bit of moisture in the air, or maybe he has a water trap separator, but they won't run an oil coalescer. A little bit of oil in the tools for a mechanic doesn't hurt a thing. A little bit for the body man, if it's, a grinder or something, really doesn't hurt a thing. Who it hurts is the guy using the spray gun, the guy blowing the car off before it gets pre-cleaned and tacked off to be painted. You don't want any type of contamination coming on the surface at that time. So ensure that enough air is supplied to all the shop's application. Air systems are run at higher pressure, and then we regulate them down at the drops to meet your specific needs. So yes, I only need 20 pounds in the booth or 27 pounds for my spray gun, but I can't have 27 pounds in that air line, because if everybody goes to work at the same time, I'm not going to have 27 pounds, right? There's going to be a pressure drop through all that stuff. So you're going to regulate up to 80, 90, 100 pounds, and then you're going to adjust your regulator based on the pressure you need at that particular drop. The best way I can tell guys to set up their spray gun: pull the trigger on the gun wide open, adjust the wall regulator till the gauge on the gun reads the pressure you want to spray at. Then when you let go of the trigger, you don't get that big pressure drop in your spray gun. It really doesn't matter what that wall regulator says. as long as you have that paint company's recommended inlet pressure at your spray gun. If it's 22, 24, 17, whatever it is, that's the pressure you want to have at the gun. So most economical, sorry, let me back up one. Makes sense to refine the air for the entire shop to help protect piping, make the air more manageable, and for downstream filters, and the filter to regulate air for specific applications at point of use. The most economical way this can be done is a refrigerant dryer managing the air for the entire shop, and then specifically designated filters at each drop of the shop. You will never get any cleaner air than having a point of use filtration where that hose is running to that body man, painter, etc. Go ahead, Kevin. So managing the air for the entire shop with refrigerant dryers. A refrigerant dryer will reduce the air temperature anywhere between 50 to 35 degrees Fahrenheit. Downstream filters to work more efficiently. It's only capable of producing a 90-degree temperature drop in the compressed air line. That's the most you'll get it to drop, and it should be a minimum of 20 feet away from the compressor in piping feet. If you go up the wall 10 feet and over and back down 10 feet, that's fine. You're 20 piping feet away, even though that refrigerant dryer might be setting 4 feet away from the compressor. That's fine. But you got to give that air time to get cooled down and those types of things before you run it through the refrigerant dryer for it to be effective. The other thing that does is by running that piping uphill, when that compressor is not running, any moisture that's in that line is going to run back to the tank on the compressor. As you can see from this diagram, we have an automatic drain on the bottom of our compressor. If your header pipe, so if you look coming out of that compressor, you got a pipe running 6 feet up and then 10 feet across. That 10 feet across pipe would be up by the ceiling. This diagram doesn't show it, but that pipe should be angled uphill a little bit of an uphill angle. So when the air compressor is not running, any moisture that's in that line runs back in that compressor tank. Then the automatic drain kicks on and takes the moisture out of the tank. It's much more easier and efficient to get the moisture, the solid content of the moisture we're talking about, out of that airstream through the air compressor tank than it is to let that moisture get all the way through the loop system and drop down through your loops and come out at your water drops in your auto drain that's at the other end. So if you run that uphill when the compressor don't run, any moisture and contaminant is going to run back down in the compressor. Auto drain kicks on, dumps everything out that way. Best case scenario. Okay. Talk a little bit about piping. What don't we want to use? Never use PVC or any type of plastic. Some guys will say, well, I can use the gray plastic. I don't know what they call that. It's good at 80 scale or whatever that is. It's plastic. Plastic is made for plumbing water lines in your house, not for air. It's also an insulator. It keeps the air hot longer, does not allow it to cool down. So if it's at 20 feet away that we talked about for a refrigerant dryer, the air is not going to be cool enough if you're using PVC. So never PVC or plastic. Okay? Black iron, okay, I get it. It's easy. You can go to Home Depot, Lowe's. You can buy it pre-threaded. Same with galvanized. Fairly easy to work with. They have some downsides to them. You can see corrosion's the biggest thing. You know, the galvanized, the zinc will start flaking off over time. The best stuff coming today down the stream, down the line, copper or aluminum. If you can solder, copper is very easy. If you don't want to get into that and you want to pay for it, the new aluminum stuff is the way to go. You cut it to length. It's all hand tight and quick disconnects. They got T's, they got 90s, they got elbows, they got everything you need. You just buy it, cut it to length, hand tighten it right together, and it's done. It's the easiest to install, transfers the heat very well, very smooth on the inside so you don't get turbulent airflow. But if you don't do anything else, never use PVC or plastic. Okay? So this shows how you size your piping for your shop. So, and there's a book in here that this information came out of, just so everybody knows, and we'll give you the name of that book and the author and all that stuff. This is not something that DeVilbiss made up and just put some numbers on a chart. So we'll give you that information so you know where it came from. So as we talked earlier, if you need a 25 horsepower compressor, okay, I'm going to look at, down that line about 3/4 of the way down on the left. I got two of them. I got 25 to 30 horsepower compressor. My CFM are both in the 75 to 120. Okay. My header and my main line. If I'm up to 500 feet, I need to go with 1.5 inch pipe. If my header line is going to be over 500 feet, up to 3,000, I need to have a 2-inch header pipe. That's going to help with pressure drop. I do not want to take 3/4 inch pipe, run out of my compressor, run 50 feet down the stream, go into my loop system, and have 1/2 inch drops for all my shot or all my five body men and 2 painters off a 25 horsepower compressor. Nobody will have any air, because it's like getting that real thick chocolate shake and having a regular straw that's made for shakes, or one that's made, the smaller one's made for pop. You can't get enough material through that small straw. You won't get enough air through a small diameter hose. So this comes from the atmospheric gas pressure people that do the testing to tell you this. So this is another good page. 35 to 50 horsepower compressor. You got 550 feet of header pipe. I need to run a 2-inch. If I'm going over 3,000 feet, I need to go to 2.5 inch header pipe. Yeah, it costs more, but the worst thing you can do is undersize your piping. You buy the best compressor in the world, and if you don't have proper size piping, you're going to have issues with getting enough air to the people that need it. And then the next slide shows what the drop leg should be. Go ahead, Kevin. And as a standard practice, I would tell everybody just go 3/4 inch drop leg. It's just easier. You can go 1/2 inch if you're only doing up to 50 feet. But if you're running, your 2-inch or 1.75 inch header pipe, just come off of that with 3/4 inch and run 3/4 inch all the way down. At the bottom of the slide right here, it's the Compressed Air and Gas Handbook. It's from the Compressed Air and Gas Institute. There's the guy that wrote the book. There's the patents and everything, that go along with that. So if you ever have any questions on anything, feel free to go to the library or order that book through whoever, and it'll give you all that information. Again, we did not make this stuff up. We just deciphered it out of this book to be able to put it in a presentation form for everybody. So go ahead, Kevin. Okay, talk a little bit now about the second part of the thief, of what's going on here. And this is, we're going to talk about point of use filtration. This particular filter here is a water trap, and this will take out water and dirt particles. This is at minimum what you should have for your mechanics, your body men, things like that. If your body men are not spraying paint. I mean, I'm going under the assumption that anything being sprayed is going to be done in a booth or on a prep deck by the painter. So body men, in some cases, I know body men are still spraying primer, then they're going to need to have something better than this. Because if you have contamination being into your airlines through where primer's being sprayed, you could have primer delamming and things like that on down the line coming as well. So this should be the minimum. Runs tools at high air pressure. Will handle large amounts of air. It's very easy to maintain. It's got a self-relieving regulator and a ball valve and a little manual wing nut drain at the bottom. So these are very popular. They're a couple $100. They're not expensive, and this is by minimum what every body man should have, or mechanic in his stall. Go ahead. Okay, this gets a little bit more in depth now. Now we're going to talk about point of use water, particulate or dirt, oil, and humidity filters. This is a line drawing of a DeVilbiss camera unit. This is the CT Plus. Air comes in from the left. You always take out water first, then you take out oil, then you take out humidity. You can't do it the other way around, or it won't take everything out properly. I can't take out the humidity, then try to take out the solid content of the water. It won't work that way. Take out the solid content of the water, take out the oil, then take out the humidity. Most are designed to move oil down to 0.01 micron or the level of cigarette smoke. This will get air cleaner than the air that you breathe right now. The other big thing about these is we got to maintain them. Different than the air compressor. These are, I don't want to take anything away from the compressor, but if it was me, I would just have the compressor people do it. This I would put on the painter. If the painter's the one responsible for the paint work, he's responsible for keeping the booth clean and sweeping it out, getting the cars clean and all that. He should be responsible for maintaining the filter unit. It's not a big deal. Again, I painted cars for a lot of years. There's a lot of downtime that painters have, that between coats of base, between sealer and base, between base and clear, you turn these ball valves off, you maintain these things. It takes a whopping 5 minutes to do in most cases. And if a painter tells me he don't have 5 minutes, 2 or 3 times a year to maintain one of these things, then I don't believe that. Follow the manufacturer's maintenance process and schedule. Determine who's going to be responsible. Do a measure or an audit for the procedures to make sure they're being done correctly. So we have 120 people on the street, our feet reps under the RSG brands. Any of our guys are happy to come in, show you how to maintain these things, go over them, talk about them, run through the same presentation if needed. Your desiccant dryers, drains, if not equipped with auto drains, make sure the drains are working. Visually check the humidity indicators to make sure that they're not showing that they need to be changed. Green is good, yellow's bad, right? Green means to keep going. Yellow means it's time to change it. Minimum, they should be changed every 6 months. Charcoal filters, drain daily as needed. Again, auto drains, make sure they're working. I think auto drains are great. Here's my perception of them. They're great as long as they're working. The problem is when they're not working, nobody knows because they're supposed to be automatic. So everybody's walked into a shop and you hear the auto drain on the compressor and you hear that psh of air that blasts out there. Sorry, my sound effects aren't the greatest. But you can adjust those. They can stay on from 5 seconds to 40 seconds. And you can have them kick on anywhere from 5 minutes to 45 minutes. So every 40 minutes, I can have that thing kick on for three or 4 or 5 seconds. As long as you continue to hear that, that's great. The problem is when you're not hearing it, it's not working. So manual drains are fantastic, but somebody has to take the responsibility that they're going to manually drain that unit every day. And to me, if you're the painter and you're the one responsible for the work, walk over and open that drain valve up on the bottom of that unit every morning and let it drain and make sure there's nothing in there. And if you want to put an auto drain on, I think that's fantastic. Just make sure you're listening for it. Make sure you know that it's working. The other thing I recommend to people when you're changing filters, take a piece of masking tape, stick it right on that filter unit and put the date on there that you changed it and just kind of look at it. If it says January 1st and this is now June 23rd and we're in the summertime and it's hot and humid in most of the country, it's probably a good time to change it. So go ahead, Kevin. Okay, air hose. Minimum, I know guys used to use 5/16 of different things, 3/8 hose at minimum for all air spray applications. And this says 35 feet long. I would tell you that a 35-foot long hose is what's recommended for an automotive spray booth, because if your air filtration unit is in the middle of the booth, that will comfortably get you around both directions of the car, from one side to the other without stressing the hose or having to pull it too tight. If you're not in a booth that big, then you want to use a hose that is as short as possible to comfortably get you around the area you're spraying. If you're in a place where they're painting 8-foot enclosed trailers, you don't need a 35-foot hose. You can get by with a 20-foot hose. Perfect. The DeVilbiss hose, resistance to heat and abrasion. They're a synthetic rubber lining. They have high flow fittings, HVLP for less pressure drop. I get a lot of guys, I'll walk into shops, we'll talk about air hose. Yeah, my hose is good. Look at it. It has a protective cover around the outside. The outside I can wipe off and it looks really good for a long time. What's the inside look like? We don't know. They get caught behind the car tire. The painter does not walk back and unhook it from the car tire. He tugs on it 2 or 3 times first. That hose gets kinked. It gets run over with the car. The hoses start breaking down from the inside out. They stay in that booth for the bake cycle. Some of these shops are, running 6, 8, 10 bake cycles a day. That hose is expanding and contracting every time it gets baked. If it's 6 months old, that's a lot of expansion and contraction of an air hose. So what I tell guys on their spray booth air hose, change it out once a year. It's not a bad hose. Go give it to a body man. Go give it to a mechanic. It's fine. Go put it somewhere else. But put a new hose in the booth. I'm not telling you to throw it away. It can be used somewhere else. It can be a backup, but put a new hose in your spray booth once a year. And I would do the same thing. Take a piece of masking tape, put it with your air filtration unit. In January, when you do your maintenance, put maintenance kit January 1st, replace air hose January 1st. And then in June, when you do your maintenance kit again, you know the next time you got to do your maintenance kit and your hose. Saves yourself a whole lot of aggravation. Nobody gets paid to repaint cars. We don't get paid for comebacks. We don't get paid to retape them. The shop doesn't get paid materials a second time. So it's a losing situation for everybody. And all we're trying to do here is give you things that are very easy to do to keep good maintenance on stuff by maintaining your compressor, maintaining your filtration, changing out your air hose once a year to let you have less comebacks, less redos, make the shop more productive, and hopefully you guys make more money as well, right? That's the idea. That's what we're all trying to do here. Go ahead, Kevin.
Hey, Jeff.
Yes, sir.
I think you just touched on a great aspect of hose abuse, if you will. And I never really had given much thought to it, but if you've got a painter's got several hoses that are in a booth and they're going through a half a dozen bake cycles a day times 5, 6 days, maybe even 7 days if it's a really busy shop. I mean that hose is really getting some abuse, so it's no wonder
Yep.
They're starting to get some leaks and they're starting to get some drops from the inside the booth filtration to the gun. That wouldn't surprise me at all. So that's a great point, and thanks for pointing that out to us.
Yeah, and that's the thing, Kevin. Guys, you can't see the inside of the hose. So yes, hoses do break down on the inside. So I just did some quick math. If a guy's painting 5 cars a day, we work an average of 220 days a year. That's 1,100 bake cycles on that hose that it's expanded and contracted, and that's also 1,100 time or cars they've painted. How many times did that hose get driven over in that time, or kinked underneath the corner of the tire, or whatever the case? So hose is cheap maintenance. It's $100 for a good quality hose. It's once a year. So this talks about another one of the thieves that's stealing our money, and it's air leaks. We've all walked into a shop. We've all heard that little fitting over in the corner that's just sitting there going, and then it's leaking a little bit. And they go, yeah, you got an air leak over there. Yeah, it's not that big a deal. Well, somebody actually took the time to calculate an air leak cost from a hose hole from a 64th inch to a 1/4 inch based on 90 PSI, 13 cents per kilowatt hour, 1 8-hour shift operating 5 days a week. So if I got a 64th inch or 1/64th inch hole leaking out of a hose, that's an awful small air leak. That air leak is going to cost me $18.21 a year just in electricity, just running an 8-hour shift. A lot of shops run 10 hours, 12 hours, 2 shifts, whatever. If I got 3 or 4 of these leaks, and now they start adding up to an 1/8 inch leak or a 3/16 leak, I could be costing myself $1,000 a year just in leaking air hoses. So sell the guy another $100 air hose. I mean, all the DeVilbiss premium hose have reusable connections on them. So if it's leaking at the fitting, you can shut the air off, take the fitting apart, cut off the bad part of the hose, reinstall the fitting, you're good to go. If they don't even want to do that, spend the $100 to put a new hose on. It's worth it. This is the extreme. I mean, a 1/4 inch air leak is a big air leak, but you get in some of these mega shops, they got, 12 body men and they run 4 spray booths. You got 5 or 6 air leaks that are real small. They add up to a 1/4 inch. They can be spending $5,000 a year on electricity just because of air leaks. It's not the normal, but it's just to bring it to your attention when you walk into shops and you see these things or you hear it. It's really easy to give something to go out and put some thought into to fix. So go ahead, Kevin. Anybody have any questions on anything yet?
We don't have any yet.
So little call to action slide here. A good shop manager has a technician that's handling the maintenance on the compressor filters and lines. Fine. A great shop manager has a technician that's handling the maintenance on the compressor, the filters, the line. He's also auditing to make sure the process is being carried out correctly in a timely manner. So I have shops that I go into that they have a maintenance guy that takes care of this stuff. I have other shops, they have an outside company that comes in, they maintain it for them. So calculate if the compressor is large enough using the enclosed chart, add the main tool to each hose and drop, right? We talked about that. Horsepower rating will be on the tag of the compressor. We know that. If it's a rotary screw, it will be listed on the side. Develop a compressor maintenance plan. I can't stress that enough. I worked at, 6, 8, 10 different shops. I think one shop I worked at, we actually had an outside company come in and maintain the compressor. Other than that, I worked at lots of shops that the compressors died and then there you are waiting for someone to show up because you have no air. Okay, so tag this stuff. Make sure you got a plan. It's a great tool. Go ahead. Okay, talk to the painter. Ask him if he's ever had any issues with not having enough air. If he has, use that chart that we talked about to see if the long runs, are they running undersized pipe. Look for excessive amounts of T's or elbows. These are all things that create restrictions going to the booth. If the guy don't have enough air, don't use the old 2-fitting blowgun, the real NIOSH unapproved one. I know they work great. I used to use them as well, but they use an awful lot of air. Get rid of the plastic piping. Develop a plan for the guys to have point of use regulators, point of use filter maintenance plans. Just because they have the regulator, doesn't mean that filter shouldn't be changed once or twice a year, right? Again, we have 120 reps on the street in North America. We have hygrometers. We will come out. We will do shop audits. We can test the air. We can tell them, is their air good quality? Is it not enough good quality? There's not a shop in the country that's running solvent today that's not going to switch to waterborne, that they're going to come out and do an air quality test and say, listen, your air quality is not good enough for you to use water. You have 35% humidity. If you have 35% humidity in your airline, you're going to fail with water. They're not even going to give it to you. You could get by with 30% with solvent, but as I mentioned earlier, if you're going to go to waterborne, you got to get under 10, and they'd like you to be under 5. Fix the air leaks in the shop. Replace the old hoses. Again, a lot of these guys do work at home. Take the hose home. Give it to a body man. It's not as important for a body man if he's got a hose that's a little restrictive or a hose that doesn't give him quite good quality airflow on the inside because he's running DAs and grinders and things like that. Where a painter and a spray gun, it makes a big difference on having good, clean, consistent airflow. Okay, next. And that's it. Again, I can't stress enough, maintenance on the compressors, maintenance on the filtration, maintenance on their hose, and get these guys good, clean quality air. They'll be more productive. The shops will be more efficient. They'll have less redos. If they save on, 1 or 2 redos a year, they're saving money, right? We all know that a redo can cost, depending on who you talk to, $500, $600, $800, $1,200, depending on how far you want to go with, lost production and everything else. So again, I'd like to thank you for your time. Appreciate everyone's interest in attending, and I'll turn it back over to Melissa and Kevin.
Okay. Well, we don't have any questions. Obviously, there were a lot of good ideas here on how to help the shop save money, which we're always looking on how they can do that. I'll follow up by sending everybody the presentation, and of course, that will include those publications where all the information for those charts came from, and we'll send them out your information so if they have questions. And I think that concludes the webinar. We appreciate everybody's time, and we'll be in touch with other training opportunities. Kevin, do you have anything to say?
I don't. Just like to thank everyone for hanging in there and enjoying the presentation. I think Jeff is a real great authority to have in this field, and if there are questions that come up afterwards, you can always reach out to either one of us and we'll get back in touch with you. But again, thanks, and really appreciate the opportunity to engage with the RDA team, Melissa.
Okay. Thanks, everyone. Take care.
Thanks, everyone. Have a good day.